The last two examples I want to look at with regards to plotting polar points is what do we do when we've got negative values? So the first set we dealt with were all positive values. So you went around in the counterclockwise direction for the angle measurement. Then you moved out however many units the radial value was. Now we've got a negative radial value. And what does that mean? Well, if I look at this is in the format of r theta for my ordered pair. My theta is pi over 6. So I'll go with pi over 6, which is about this line right here. And instead of me going out 2 units, since it's negative, I'm going to go backwards 2 units. So my ordered pair is going to be in the third quadrant. So the polar point, negative 2 pi over 6, is in the third quadrant, 2 units backwards from the direction of pi over 6. Number 27, we've got negative 2, negative 3 pi over 4. Once again, this is in the r theta format. So we're going to go negative 3 pi over 4 and then 2 units backwards. So negative 3 pi over 4, this is 0. We know we're going to go in the clockwise direction. So right here would be negative pi over 2. And this guy right here would be our negative 3 pi over 4 line. So instead of me going 2 units this way on this negative 3 pi over 4 line, I'm going to go backwards 2 units. So that negative 2, negative 3 pi over 4 is actually in the first quadrant. It's the same thing as if I were to have written it as a positive 2 and a pi over 4. So that's really what we want to look at as we conclude this section. With polar coordinates, it's possible to name the same point multiple ways. In fact, we can name every point an infinite number of ways. So if we look back at our previous examples, what are different ways that we could write the same exact point? So for example number 1, we had the point 1 comma pi over 2. And if I pull out my page, there's my graph of it. It's at the point 0, 1. What's another way that I could have written the ordered pair 1 comma pi over 2? Well, 1 comma pi over 2 is going 90 degrees and then walking 1 step up. I could have done the exact same thing by going 5 pi over 2 and then 1 step up. So I could add that 2 pi, get a coterminal angle. The other way I could have done it is I could have gone to 3 pi over 2, but since I'm facing downward, I would then have to go backwards 1 unit to get to the point 0, 1. Or if I wanted to do it in yet another way, I could say I'm going to go negative pi over 2, which would just be down 90 degrees in the clockwise direction, and then go backwards 1. Remember, all these are in the format of r theta, so your angle is the second measurement. Example B you had was 3 and pi over 4. So the first way is 3 and pi over 4. And if I wanted to, I could add 2 pi to that and get 3 and 9 pi over 4, the coterminal angle. I could also go in the negative direction. If I were to go to negative 3 pi over 4, I'm facing the third quadrant, but this point is in the first quadrant. So that means I'd have to go backwards 3 steps. So there's another way that you could write that same ordered pair. Letter C we see up at the top here. It was negative 2 and pi over 6. So I can see it's this pair, this point right here, and we got that by going pi over 6 facing this angle, then going backwards 2. But I could have just as easily gotten that point by saying I'm going to go around to 7 pi over 6 and then going out 2 units. So I could have said this negative 2 and then pi over 6 is the same thing as me going to 7 pi over 6 and then going out 2 units. Or to get to this angle, I could have gone all the way backwards. This is also a negative 11 pi over 6 if I go in the clockwise direction. So if that were to be negative 11 pi over 6, that means my angle would have been negative 2 backwards. And then finally for the last one are negative 2 and 3 pi over 4. I could have looked at that as going around the whole unit circle and getting a coterminal angle, or I could have looked at it as just going up from 0. So let's take that approach. Right here, this we said was negative 3 pi over 4 coming around here and then going backwards the 2 steps. We could have just as easily said, hey, let's just go up to pi over 4 and outward 2 steps. So we'll go positive pi over 4 and then outward 2 steps. And as I said, if you wanted to continue around, you could say 9 pi over 4 and then going outward 2 steps by adding that 2 pi. So if I were to summarize all those points, there's 2 formulas we can look at. In the formula format, it could be in the pattern r comma theta, which is our polar format, which is r, and then theta plus or minus 2 pi n. That should look very familiar to you. You keep the same r value, but it's every single time you go around the unit circle. The other way we could look at it is look at it from changing the direction we go. And if we do that, there's our formula that we end up with. Theta plus or minus 2n plus 1 pi. Now you might look at that and say, what is that saying? Well, let's look at this in plain English. The first formula is saying if I want to have the same direction, which means the same r value, all I'm going to do is add or subtract 2 pi. If I'm going to switch direction, which means I'm going to have the opposite signed r value. So if it's negative, it becomes positive. If it's positive, it becomes negative. I'm only going to add or subtract pi. So that's the English way of saying those 2 formulas. If I want to keep the same r value, I'm going to add or subtract 2 pi. If I'm going to take the negative r or the opposite of r, I'm going to only add or subtract pi.